Hello, welcome to our KNJ Math Academy channel. Today we are going to have our first video covering the relation and function for Algebra 1. In addition, later on we are going to upload more videos for the rest of topics in Algebra 1. Let's move for the first sheet here. So I'm going to start with some quick definition about the topics we are going to cover in this video. So relation. What is a relation? It is actually a set of ordered pairs. Like this example we have inside the parentheses. I have minus 4 and 4, minus 4, minus 2, 4 and 4, 4 minus 2, and 0 and minus 4. So before moving to the next definition, let us first try to draw this one in xy axis. And as we know that for the x-axis the right is my positive and the left is my negative. Up for the y-axis is the positive and the down is the negative. Okay, so I'll start with minus 4 and minus 4, and also I'm going to assume each square represents 1. So minus 4, it means I'll go 4 to the left, 1 2 3 4, and 4 up, 1 2 3 4, so it will be somewhere here. Minus 4 minus 2, 4 to the left, 2 down, 4 and 4, 4 to the right and 4 up, 4 minus 2, 4 to the right and 2 down, 0 and minus 4, that's actually the intersection for y-axis, so it will be in 1 2 3 4 somewhere here. Okay, I can also very quick try to draw for the next example minus 3 and minus 3, so it will be somewhere 3 to the left, 3 down, 0 and 1 will be over here, 2 minus 4 is 2 to the right and 4 down, 3 and minus 3, so 3 right and 3 down, minus 2 and minus 4 will be somewhere here. Okay, the next definition will be the domain. Domain is the set of all x coordinates. It means all of these values for x coordinates. I have minus 4, minus 4, 4, 4, and 0. The range is a set of all y coordinates, so that's all y values here in green. 4 minus 2, 4 minus 2, minus 4. We can also try to write this domain and range inside the parentheses. So domain will be here minus 4, and I'm not going to write the repeated number, so I have minus 4, minus 4, 4, 4, and 0. So I will have minus 4, 0, and 4. Yeah, it will be nice to make it in order. Let me pick the other color. Range. So in the range here I have minus 4, minus 2, 4, minus 2, minus 4. So I will start with the least, minus 4. And I have minus 2. And I have 4. The last definition here for a function. So the function is a relation that has a one-to-one relationship. It means for each x value you have a unique y value, is not more than 1. If you have more than 1, so it is not a function. So for this example, let me pick another color. The first two pair, I have minus 4 and 4 and minus 4 and minus 2. So for the same minus 4 value for x, I have two different y value. So this is not a function. Okay, but for the second example, so I have minus 3, 0, 1, 2 minus 4, 3 minus 3, and minus 2 minus 4. Yeah, we can first start getting the domain like the first example. So the domain will be, I have minus 3, 0, 2, 3, and minus 2. I have minus 3, minus 2, 0, and I have 2, and I have 3. The range, I have minus 3, 1, minus 4, minus 3, 1, minus 4, minus 3, minus 4. So I have minus 4 repeated, minus 3, and I have 1. That's it for the range. Yeah, minus 3 repeated twice, minus 4. So that's repeated twice, and I have 1. Okay. Is it a function or not? So let's check. I have pair by pair, minus 3 and minus 3, 0, 1, 2, and minus 4, 3 and minus 3, and minus 2, minus 4. For each x value, I have a unique y value. So actually, this is a function. Okay. So let's move for the next sheet. It's more exercise in order to reinforce the concept about the domain and the range. So let me pick the color. So state the domain and range for each, and then determine if they are functions or not. So for the first one, that's actually my domain. So my domain is minus 2, 0, minus 2, and 5. So minus 2, 0, and 5. The range is the y coordinates. So minus 1, minus 3, plus 3, and plus 4. So my range will be minus 1, 3, 3, and 4. So minus 1, 3, and 4. Is it a function or not? So we can check the first pair, minus 2, minus 1, 0, 3, minus 2, and 3. So I have these pairs for the same x value, which is minus 2. I have two different y values. So this is not a function. Okay. The next example, the range, or sorry, we'll start with the domain first. The domain, it's all x coordinates. So my domain, I have minus 1, 0, 1, and 0 repeated again. So I have minus 1, 0, and 1. And what is my range? That's all y value. So I have 5, 3, 10, 7. Let's make it in order. 3, 5, 7, and 10. Is it a function or not? So I have, let us look for all pairs one more time. It's minus 1 and 5, 0 and 3, 1 and 10, and 0 and 7. So I have here 0. The same x value, I have 0 and 3 and 0 and 7. So for the same x value, which is 0, I have two different y values. So this is also not a function. Okay, let's move for another way how to determine if it's a function or not by the graph itself. So here is the rule. So if you draw the vertical line, that's what we are calling vertical line test. If you draw any vertical line for any drawing or mapping for those relations, we have to be careful it is a relation until we confirm it's a function or not. And if you have the intersection in one point only, so that's a function. If not, so that's a relation. So let's start with the first one. So if you come over here and make a vertical line, so I need only one to determine. So here I have two points, so that is not a function. If I move to the other one, if you make any vertical lines, so in all vertical lines you have only the intersection is 1 point, it is going only through 1 point, so this is a function. It is the same also for this one. If you draw all of these vertical lines, it is passing only or intersection only 1 point, so that's a function. The last one here, it is the same, drawing all of these vertical lines, so the intersection in 1 point goes through 1 point only, so that is also a function. Okay, the last thing I'm going to cover in this video for relation and function, about the concept that since we have a function which is spatial pairing between two sets of numbers, so we can represent this function using a two variable equation. And if you have this two variable equation and you have one of those pairs, so you can get the other one by solving this equation. The example we have here is 2x plus y equal 9. And let's have some exercise in order to get the other pairs. Let me make another color. So the first one here, 1 and something. So my x is 1 and y I would like to get through this equation. So it is 2x plus y equal 9. Here my x is 1. So 2 plus y equal 9. So y equals 7. So after solving this solution, the other pair is 7. Okay? Let's move for the next example. So it is the same variable, the same function, the same equation we have is 2x plus y equal 9. In this case, x is 5 over 2, so it's 2 multiplied by 5 over 2 plus y equal 9. If you simplify this one, you will get 5 plus y equal 9, so y equal 4. So by solving this solution here, I got the other pair for this function. The next one here, I have my y is 9, so it is 2x plus y equal 9. That's my equation. So I will replace y by 9. So 2x plus 9 equal 9. So if you subtract 9 from both left and right, it will give you 2x equals 0. It means x equals 0. So this pair is 0 and 9. The last one I have, it is the same equation. I have 2x plus y equal 9. In this case, x is 4. So 2 times 4 is 8 plus y equal 9. I can subtract 8 from left and right. So here y equal 1. So my pair here is 4 and 1. So that's it for today. I hope you enjoyed our video. If you enjoyed and want to hear from me again, be sure to subscribe and hit the notification bell button before you go, so you will be notified for any future videos. Thank you so much.